Well, for this problem, you can let Excel find the mean and standard deviation for you. So test statistics, students believe that the mean score on the first statistic test is 65. The instructor thinks that the mean score is higher. She samples 10 statistics students and obtains the score. Now, do the test with level of 5% significance. She thinks it's higher, so your alternative hypothesis is mean greater than 65. Now to find these other values, we're going to use Excel. Our sample size was 10, and I typed the data right here, so then Excel can find the mean of the sample and the standard error. So to find the population that comes from your null and alternative hypothesis, it's 65. To find the mean, you could add all of them up and divide by how many there are, or you can allow the Excel to do it. For Excel, you click where you want it, you put equals for a formula, and mean is also called average. If I start to type average, notice the second one says average. Double click it and then highlight your data. To highlight it, you left click and drag it down and then hit enter. And there's your sample mean. No, they didn't ask for the standard deviation, they asked for standard error. So to find standard error, you do find standard deviation. So if you type ST for standard deviation, it's the sample one, because this is a sample. This one is the population. So we double click the sample one, highlight our sample. Now that is the standard deviation. But we wanted the standard error. So to find the standard error, you divide by the square root, so we could type square root. Notice it came up. Double click it, and we want n, which was 10. So that's your standard deviation of sample means, or standard error. And then alpha was 0.05. Now, we should have just put standard deviation here. To find standard error, so this one's standard deviation. Now to find standard error, you take standard deviation and divide by square root of the sample size. And so that's our 3.4575. But to find your test statistic and stuff, you want to leave this as the standard deviation. But if they ask for standard error, just divide by the square root of n. Here's your test statistic. Your p-value, we were testing greater than, so that would be a right tail, 0.0346. Then you compare the p-value at alpha. 0.05 was alpha, so alpha is greater. If p is less than alpha, reject. So we reject. The other one be the same thing, typing the values 6, 4, 4, 4, 5, 6, 3, 6, 5. That's gonna, these will not be correct because there was more than, I think there's 11. 6, 7, 8, 9, 10. Oh, there's 12. I think I missed one. 6, 4, 4, 4, 5, 6, 3, 6, 5, 6. Oh, they're all there. Okay. So our sample size is 12. Population mean is 4. This is a t-test because the sample size is small. We're using mean. Null would be equal to, it's always equal to. The alternative is the same values, but we're testing. If they have more cavities, so we're testing greater than. The test statistic will be t, because we said it's a t-test. And then we need to find the value. Population mean comes from the null and alternative hypothesis, so it's 4. The sample mean, we need to use average, so equals average, and then highlight our data. If the data would have been the sample same size, it would have already calculated it, but standard deviation, re-highlight the data. Alpha 0.01. We didn't need standard error, so we can just delete that. And then our t-value, 1.239. P-value, we were testing a right tail again because it was greater than. Sometimes on these they want the percent, so you just multiply by 100. Okay, so if we look at the p-value, 0.12, and the alpha is 0.01. So the p-value is definitely greater than alpha. If the p-value is greater than alpha, fail to reject. The data suggests the population mean cavities is not significantly more. To interpret the p-value, if the population mean number of cavities is 4 in the survey of 12-year-olds. Now here they're multiplying it by 100 to get the 12.048. And the last one, this uses the the alpha 0.01. Is that the only one? Yeah, that was the second one.